So, first day of semester 1 final review with your practice packet. Okay, I picked and chose some problems to go through. So, first one I'm going to start with is number 2. Okay, so number 2 is with the segment addition postulate that we talked about. What do I know about 9 and 2x minus 13 compared to x plus 6?
They add up to x plus 6.
Right, these two add up to the whole thing, which is x plus 6. So I'm going to set it up that way. So to set that up, I do 9 plus 2x minus 13 equals x plus 6. And then it's just an algebra problem where we solve from here. Okay, I'm going to combine like terms on the left side. So I have 2x minus 4 equals x plus 6. Doesn't matter which way you solve and what you take over to whatever side. It does not matter. I'm just going to subtract x. So I have x minus 4 equals 6. And then last step, I add 4. So we get x equals 10. The value for this one, it only wanted x, but on your test, if it wants to know the value of UW, how do you find that? You would fill it in, right? You could plug it into here, or you could plug it into this one and add it to 9, either way. And so just make sure we're reading directions carefully on what it wants. Okay. Number 4, again, if you have questions, please ask them. Okay. Number 4, biggest thing with this one, it is very similar to the one that we just did. It's just with an angle now. Okay. Biggest thing is making sure you fill in the correct information in the correct angles. Okay. So ZKJ, this angle right here, is 9x minus 12. LKZ is this angle, and that equals 76. What is LKJ? 14x plus 4, what's that? So the whole thing, right? So this whole thing is 14x plus 4. So very similar to the one that we just did up top on number 2. What do I know about these two compared to the whole thing? Add up together to equal the whole thing. So 76 plus 9x minus 12 equals 14x plus 4. So to solve from here, I'm going to combine like terms on the left side. 9x plus 64 equals 14x plus 4. Then we just solve from here. Subtract 9x. So I have 64 equals 5x plus 4. And then subtract 4. 60 equals 5x. Divide by 5. What'd you guys get for x? X equals 12. Good. Any questions on 2 or 4? All right. When you get to 5 through 12, I believe, these are with our vocab terms. Okay, so I'm going to go through each one of these. These are with our parallel lines and transversals. So if I'm looking at number 5, remember the trick to help you with these is if you treat this like a box. Okay. First, ask yourself, are they inside or outside of that box? Outside. They're both on the outside, so that means they are exterior. And then the other part we have to check is what side of the transversal they're on. Are they on the same side or opposite sides? Opposite, so that is alternate. So the relationship here is alternate exterior. Number 6, same thing. Draw the box to think about it. Are they inside or outside? Inside, so that would be interior. And then compared to the transversal, same side or opposite sides? Same side. Yep. So same side, interior. What did I say you can call this one? You can just abbreviate this one to SSI. Number 7. What did you guys put for number 7?
Adjacent.
It is adjacent. What does adjacent mean? Right next to. Okay. Angle A and angle B are right next to each other, making up another angle. Okay. There's no other word to describe those two angles other than they are just right next to each other. Okay. So that one is adjacent. Number 8. Again, we have our 2 parallel lines and a transversal. Are they inside, outside, or both? What was it when it was both and they are on the same side? Corresponding. Yep, it's that kind of weird one. Okay. Page 2, the 9 through 12, these are still our vocab terms, so let's look at these. On number 9, are they inside or outside? Inside the box, so that means interior. And then of our transversal, are they on the same side or opposite side? Opposite, so that means alternate interior. Good. Number 10, what did you guys put for number 10? It is complementary. How many of you put adjacent at first? I would accept adjacent to because, yes, they are right next to each other making up an angle, but complementary would be a better choice because what does complementary really mean? What does complementary mean? They add up to 90. Complementary means they add up to a 90-degree angle. Okay, complementary is two angles that add up to 90. Number 11 we should be very familiar with because we use it all the time. What kind of angles are these? Vertical angles. Okay. And then the last one here, we use these ones a lot also. What do we know if they're on a straight line? What do we know about those? They equal 180, so that means they are supplementary angles. Linear pair means the same thing. We were just used to supplementary. Okay, I agree those are also adjacent, but supplementary would be a better option. Okay. Number 13 through 20, okay, they are the same idea. 13 through 16 is just asking for a specific value. There's no algebra involved. Okay, when you have parallel lines in a transversal, you have two options for what the value can be. Okay, they can either be the same or they can add up to 180. So you just have to decide between the two. On number 13, do those look the same or are they different? They are different. This one is obtuse, this one is acute. So since they're different, how do we find the other value? Yep, 180 minus 119 is 61. On number 14, what kind of angles are those? Vertical angles. So if this is 80, what is this?
80.
Also 80. Number 15, are those angles the same or are they different?
Same.
They are the same. They're alternate interior angles. So if this is 98, what's this one? Also 98. Number 16, we work with these a lot. What do we know about two angles that are on a straight line? They add up to 180. So we do 180 minus 130, which is 50. Any questions on those? All right, 17 through 20 is very similar. It's just with algebra. So I want to look at number 18 for an example. So ask yourself, are they the same or are they different? They are different. Okay, one of them's obtuse, one of them's acute. So how do I find the value of x? What do I know about those two angles? They add up to 180. So I'm going to add them up. X plus 64 plus x plus 134 equals 180. So then I solve. I'm going to combine like terms on the left side. So I have 2x plus 198 equals 180. And then two-step algebra, subtract 198. So we have 2x equals negative 18. Last step, divide by 2. X equals negative 9. Is it okay to have a negative x value? It is okay. Okay, whenever you plug it back in though, should you get a negative or should it always be positive? If you plug it in, it should be positive because can the distance of a line or an angle ever be negative? No. Okay, so don't freak out if you get a negative x value. It is okay. Okay, x values can be negative. Another one I want to look at in that section is number 20. So go ahead and flip to page 3. Number 20, same idea here. Ask yourself, are they the same angle or are they different angles? They are the same. They are alternate exterior angles. So if we say they're the same, how can I set up an equation to solve for x? Set them equal to each other. So I have 12x plus 6 equals 13x minus 1. Again, does not matter how you solve. You just want to get x's on one side, everything else on the other. So I'm just going to subtract 12x. So we have 6 equals x minus 1 from here. Add 1. So we have x equals 7. All right, number for the midpoint. Okay, also don't worry, I will not make you memorize those formulas. I will give them to you. Okay, so you do not have to memorize these. You just have to know how to use them and when to use them. With midpoint, all we're doing is we're taking the average of the x's and the average of the y's. Okay, your answer for midpoint is going to be written as an ordered pair. Okay, understand ordered pairs are always in the form of x, comma, y. Okay, so when I see us labeling these sometimes, I see this a lot. Okay, what should it be? x1, y1. Yep, remember that subscript 1, that's just for the first coordinate. Okay, and then the next one is going to be your x2, y2. Okay, so plugging it into our midpoint formula, what is my x1? -9 plus 9 divided by 2. Are you ever going to divide by anything other than 2? No. And then y1 is 0 plus -8 divided by 2. So what's -9 plus 9? 0. What's 0 plus a -8? -8. And then simplify if you can. What's 0 divided by 2? 0. What's -8 divided by 2? -4. If you cannot simplify them, leave them as fractions or you can write them as a decimal. Okay. Questions on midpoint formula? Okay. Distance formula, there's a little more going on. I'm going to look at 23. Okay. Biggest thing with the distance formula is understanding that the square root will not go away until the end. Okay. Also, another big thing is being careful of what signs you are using. Okay, so we have x2 minus x1 squared plus y2 minus y1 squared. Okay, so notice we have subtraction in the parentheses, and in the middle we have addition. Okay, so again we have our x1, y1, x2, y2. So following our distance formula, what's my x2? -6 minus -7. What happens to those two negatives? Yep. And then don't forget squared plus y2. -5 minus -8. Yep, be careful with those. Those two negatives turn into positive. So be careful when you have negatives in your coordinates. Okay, be careful when you're subtracting those. Keep simplifying. What's -6 plus 7? 1. What is -5 plus 8? Yep. So then again, squared means multiplying it by itself. What's 1 squared? 1. 3 squared? 9. So just add those together. What's 1 plus 9? So is my answer 10?
No, square root of 10.
Yep, square root does not go away. Can I use the square root? No, there's no such thing as a simplified version of square root of 10. What did I tell you if you cannot simplify? Yep, just keep it as the square root of 10. For example, on number 24, you should have ended up getting square root of 25. Can I simplify square root of 25?
Yeah.
To what? Yep, common misconception. A lot of people say square root of 5. Is it square root of 5 or just 5? Just 5. Okay. So biggest thing with distance formula that gets people is being careful when we're subtracting negatives. Okay, so be careful with that. Last one with the formula today is the slope. Okay, we used this a lot last chapter, finding orthocenter. Okay, biggest thing, what needs to be on the top? X's or Y's? Y's have to be on the top. So y2 minus y1 over x2 minus x1, because slope is always considered to be rise over run. So y's have to be on the top. I want to look at number 26 on this one. So we have x1, y1, x2, y2. So what is my y2? 17 minus 16 over
Negative 9 minus negative 9.
negative 9 what turns into addition. Yep. 17 minus 16, 1. Negative 9 plus 9, 0. Can I take 1 divided by 0? Or anything divided by 0? No. What is the answer when we're talking about slope? What is our slope? Undefined. Yep, when we're talking about slope, remember we call it undefined if we're dividing by 0. Okay. Real quick, on number 25, you ended up getting 2 over negative 6. Can I leave it like that?
No.
What should it be?
Negative 1/3.
Yep, simplify this to negative 1/3. Okay, so always simplify when you can with all three of these, the midpoint, distance, and the slope. Always simplify when you can. Okay. 27, 28, and 29, that's just reviewing scalene, isosceles, and equilateral and what all those mean. Okay, 27, what'd you guys put?
Scaling.
It is scalene. What does scalene mean? Why did you know it was scalene?
All the sides are different.
Right, all the sides are different and all the angles are different. So if they have nothing in common, that is scalene. What about 28? Yep, what does isosceles mean? 2 sides are the same and 2 angles are the same. Okay. What is it called? 21. We are looking at 29 when everything is the same. Yep, if everything matches, then we have an equilateral triangle. Okay. Getting into triangles, what is the big fact that you know about triangles?
All the angles
All the angles add up to 180. So looking at number 30, if I know 2 angles, can I find the third one? What are the steps to find it?
add 2 angles and then minus 1.
Yep, 70 plus 45 gives you 115. What do I do with that 115? Yep, take 180 minus 115, which equals 65. Again, is there any such thing as a negative angle measure? No. Okay, so be careful with that. Okay, I'm going to look at number 33 next. The directions tell us it wants us to find the measure of angle A. But in order to find the measure of angle A, what do we need to find first? Have to find what x equals. Question, what does this little box mean? 90. Yep. So, again, what do I know about all angles in a triangle? Add up to 180. So, how can I set this up if I know they all add up to 180? Right, we're just setting them all up, adding them together, equaling them to 180. So what I just did is I took all of these and I added them together to equal 180. So again, it just turns into algebra. I'm going to combine like terms on that left side. So I get 2x plus 196 equals 180. So now two-step algebra. Subtract 196. So we have 2x equals negative 16. Last step, divide by 2. X equals negative 8. Again, is it okay to have a negative x value?
Yeah.
You can have a negative x value. Okay, how do we find the measure of angle A?
Plug it in.
Plug it in to that equation right there. So we have negative 8 plus 43, which is 35. Okay, so again, I want to emphasize it is okay to get negative x values. Okay, just when you plug it in, just make sure you have a positive answer. Okay. All right, 34 and 35, same idea. What do we know about triangles? All angles add up to 180. Can we find this angle right away? What do we have to do first? We need to find this angle right here. How do I know how to find that angle? Because it's on a straight line, so I know that these two add up to 180. So I take 180 minus 120 to get 60. Is 60 my answer? No, 60 is this angle inside here. Now can I find the question mark? Right, because we know 2 angles, I can find the third one. So same thing that we were doing up above. 60 plus 50, 110. And then to find the third one, we just subtract that from 180 to get 70. Okay. Last thing we're going to talk about today, and that's our triangle congruency theorems. Okay, I will give those to you so that you have them. Okay, I will give you those 5 terms. When you're looking at these, what are the things you can assume, or when can you assume? When they're connected, right? So what are they connected by on number 36? An angle. So what can we assume with that angle? That they're congruent, right? So can I assume anything else? Like, can I assume this side's congruent to this side? No. Okay. So remember, only assume what they're connected by, and then check if it matches one of our 5 theorems. Does it match one of them?
Yeah.
It is angle, side, angle. Does order matter on these? Yes. So just making sure that it goes in the order of that specific theorem. Okay. Number 37. Are they connected?
No.
No. So can I assume, for example, that this side is congruent to this side? No. Okay, I can't assume anything, so we got to use what we are given. Okay. So right now I see angle, side, side, and I see side, side, angle. Are either of those one of our options? No. So what's my answer? NA, or cannot be determined, or none. Okay, so remember that is always an option to you. Okay. Let's look at those last 4. What about number 38? Can I assume anything? Right, we have vertical angles here, so I know that that's a right angle. Okay. Now we check one of those. Which one should we check first? YHL. Because we have a right angle. Does this satisfy HL? It does, okay, because we have a hypotenuse and we have a leg. And big thing, we have our right angle. Okay. 39. What can I assume on those? What they're connected by is congruent. Can I assume anything else? No. So now we check one of those. Which one does it satisfy? Yep. Good. 2 more here for today. Number 40. What are they connected by? An angle. So we know these are congruent. Which triangle congruent statement does it satisfy? Angle, angle, side. Last one, 41. Are they connected? No, but it should be your favorite. Why? All the sides are the same, so we should get side, side, side. Real quick, there was not an example like this, but if I had these 2 triangles, and I knew that this angle and this angle were congruent, this angle and this angle are congruent, what else can I assume? The line connected is the same, so what's the congruency statement? Angle, side, angle. Yep, so if they're connected by a side, remember you can assume that that side is the same. Okay?